Hello, fam. This is Zekaya from Entertainment, reminding you that enthusiasm implies excellence. The question we are going to look at today is a very interesting question on trigonometry. The question was posed by Kgosietsile Seoposengwe from Thabane High School, located in Galeshewe, Kimberley, Northern Cape. The question wants us to determine the general solution of the following equation. 6 sine squared x plus 7 cos x minus 3 equal to 0. Well, before we even start this question, please note the following. We know that sine squared x plus cos squared x is equal to 1. That's something that we know. And this implies that we can write sine squared x as 1 minus cos squared x. So now we can go back to our equation, and then we have 6. Instead of sine squared x, we write 1 minus cos squared x plus 7 cos x minus 3 equal to 0. This was helpful in a sense that we have managed to make this equation to sound the same. So now the only trigonometric ratio that we are going to pronounce here is cos x. We are no longer pronouncing sine x. So we have written everything in terms of cos x. So let's go ahead and remove this bracket. So this is 6 minus 6 cos squared x plus 7 cos x minus 3 equal to 0. And we can write this as follows. If we're adding the like terms there, we remain with negative 6 cos squared x plus 7 cos x plus 3 equal to 0. From here, we can divide throughout by negative 1. We can divide everything by negative 1. Remember, we are dividing throughout. So even 0 deserves to be divided by negative 1. So this gives us 6 cos squared x minus 7 cos x minus 3 equal to 0. So what do you notice here? So I'm going to write this again as a note. So this is worth noting that we have a quadratic equation in terms of, this quadratic equation is in terms of cos x. Now we have a quadratic equation in terms of cos x, not in terms of x, but in terms of cos x. So you can go ahead and use our famous quadratic equation to find the two values of cos x, or if you are familiar with what we call the trial and error method, you can go ahead and use that. So if I'm going to use the trial and error method to find the factors of this. So let me write it here on the side. By looking at 6, I can write 6 as 2 times 3. So I'm writing the two factors of 6 like that. And then the factors of 3, I'm going to write them as 3 and 1. This allows me to say 3 multiplied by 3, and that gives me 9. And 2 multiplied by 1, that gives me 2. And now, if you can take a look at this sign over here, the one that I'm highlighting in green, it wants us to subtract those two results. So 9 minus 2 gives us 7, which is precisely the middle term there. 7 is the middle term there. So now I can extract my factors like that. Those are my factors. So my factors mean that we have, this means that we have 2 cos x going along with 3, and another factor will be 3 cos x going along with 1, and then we have equal to 0. Now that sign which is highlighted in green there says the signs are different. Now that we know that the signs are different, we go now and check the sign highlighted in pink. It says the bigger number must have that sign. So now the question that you should ask yourself, who is bigger, 3 over 2 and 1 over 3. And the answer to that question is that 3 over 2 is bigger. So that's the negative is sitting next to 3 there, and then the other one will have a positive. Therefore, we have two values of cos x now. We have cos x being equal to 3 over 2, or we have cos x being equal to negative 1 over 3. Those are the two values of cos x. However, remember that cos x waves between -1 and 1, and 3 over 2 is equal to 1,5. That's already outside the interval in which the function of cos x waves. So it means that we should note that cos x cannot be equal to 3 over 2. So we only have one possibility. The possibility that we have is that cos x is equal to negative 1 over 3. Now we find the general solution of this. So for a cos function, the general solution will be x is equal to arc cos negative 1 over 3 plus k times 360, where k is an integer, or x is equal to negative arc cos minus 1 over 3 plus k times 360, where k is an integer. Now, we are done with our general solution. So now, all that remains is to use our calculator to find the value of arc cos negative 1 over 3. There is my famous calculator there. Let's see, we have shift cos, and we have negative 1 over 3. That's what we have. Then we close the bracket. Let's see what we get. We are getting 109.47. We are getting 109.47. So this is the same as 109.47 degrees plus k times 360. Another value would be negative 109.47 plus k times 360 degrees. So these are your two solutions for cos x equal to negative 1 over 3. I'm highlighting them in pink there. So that's how this question was supposed to be attacked. So this is the general solution of this equation. Now let's look at the second question. The question was posed by the same learner, Kgosietsile Seoposengwe from Thabane High School, located in Galeshewe, Kimberley in the Northern Cape. Now this question says, given x plus 1 over x equal to 3 cos a and x squared plus 1 over x squared equal to 2, determine the value of cos 2a without using a calculator. Now, let's take this equation here. X plus 1 over x being equal to 3 cos a. From this equation, if I can square on both sides, I think I can get these terms over here on the left-hand side. So let me square both sides on this equation. So let's square. So if we square both sides here, we have x squared plus x times 1 over x, that is 1, 1 times 2, that is 2. We're just removing this bracket. Another way in which you can just write it twice, then multiply manually. And then we have plus 1 over x squared. So what I'm writing there is a result that comes from what I'm going to write here in red. When we have x plus 1 over x all squared, you can also write it as x plus 1 over x multiplied by x plus 1 over x, like this. Then you multiply manually. It's just that I'm used to this, and I'm pretty sure that you can get used to this if you practice consistently. So that's what we have. On the right hand side, 3 also deserves the square. Cos a also deserves the square. So we have 9 cos squared a. We have 9 cos squared a. Now, what I'm going to highlight, if you look at this and this, x squared plus 1 over x squared, you are told that quantity is equal to 2. and you still have another 2 there. You still have another 2, and this is equal to 9 cos squared A. So this means that 4 is equal to 9 cos squared A. And therefore, our cos squared A is the same as 4 over 9 if we divide by 9 on both sides. So now, remember, even in your formula sheet, one of the expansions for cos 2A is a very interesting one, and it's relevant to this question, is the one which says 2 cos squared A minus 1. That's one of the expansions for cos 2A. And remember, cos 2A is exactly what you are required to find. And luckily, you now have cos squared A. So we have 2, instead of cos squared A, you have 4 over 9 minus 1. So this is the same as 8 over 9 minus 1. And we are not supposed to use a calculator, remember? So you are inclined to find the LCD. Then 9 goes into 9 once. 1 times 8, that is 8. Remember, 1 is the same as 1 over 1. 1 goes into 9 9 times. And then 9 times 1. So you have a minus 9 there. So the answer there is negative 1 over 9, because 8 minus 9 is the same as negative 1 in the numerator there. So we have managed to find the value of cos 2A without using a calculator. So we thank Kgosietsile Seoposengwe from Thabane High School in Galeshewe, Kimberley, Northern Cape, for posing this wonderful question. From Entertainment, we thank you.